Okay, today is our first day of review for our word problem trig test that's coming up a couple days from now. Specifically, we have a day of review today, we have a day of review tomorrow, and then the test is the next day. All right, so to start with, if we wanted to go from B to E, what would be the bearing to go from B to E? And kids, you got the answer, and this would have been the right angle we were looking for there, not the 12. The bearing goes from 0 around, so that would be 90 minus the 12, which would be a 78-degree angle. How about the bearing going the other way then? If you had hiked to here and you wanted to go back home, that's a totally different number. Generally, it's about, well, a little less than 270. What did you come up with? 258? Raise your hand if you had 258. Okay, good. All right, I think you're getting the idea. The alternate interiors involved here would have told you that that one right there was 12. Why? Because I can set up the alternate interiors by drawing out these like lines that are perpendicular to each other. Like that, and then you can more easily see, oh yeah, these 12s, they kind of go together. They're alternate interiors. Okay, so now let's go back to the very beginning. A very good place to start. ABC. Would you tell me what the cosine of that angle would be? There can be questions that easy on this test, but they would, of course, be our two-level questions. But you're going to find that after we've been doing these super hardcore word problems, these will feel like a refreshing glass of water after wandering in the desert of difficult word problems. So, what was it? What do you think? Cosine of the theta is B over C. Raise your hand if you had that one right. Awesome. Next, I had you memorize some right triangles, the 30, 60, 90, and then the 45, 45, 90. And so now, instead of just kind of guessing what they are, if you know what they look like, I'd sketch them to try to answer these two questions. Without a calculator, what is the cosine of 60 degrees? If you draw out that classic 30, 60, 90 triangle, you'll be able to figure out the cosine of 60. Next, I'd like you to do the tangent of 45 degrees. I'm going to pause for a second while you sketch out those classic right triangles. Try to remember how to do these. So, if I make this my 30, my 60, and my 90, 1, 2, root 3, and this 1, 1, root 2. Then, if I want to, you can draw them in any orientation you want. Like, for other words, this one could have been like this, 1, 1, root 2. It's fine, as long as the ones that are 1s are across from the 45s. All right, so then, cosine of 60. I go to my 60, cosine's adjacent over hypotenuse. You should have had 1/2. Raise your hand if you had 1/2. Awesome. Then, tangent of 45. Pick either 45, doesn't matter because they kind of mirror each other. So tangent is TOA opposite over adjacent. 1 over 1, also known as 1. Good with that. Okay, next, let's go to some nice, simple, I've got one side and one angle kind of questions. Let's say this side is 14, and let's say this angle is 54. Would you please figure out how long the hypotenuse is? I'm going to call it C. I'm going to pause for a second while you set up an equation and you figure out how long C is. Without these basics, those word problems become meaningless because we do the word problems so we can get it down to one like this. If you don't know how to solve this, then you can never do the word problems. Okay, I hope you were thinking, I have the opposite and the hypotenuse. So in SOHCAHTOA, I have the opposite hypotenuse, that's sine. Sine of 54 is equal to 14 over C. Now, I like to do a little switch-o, change-o, and switch these two. Did you know you can do that? Turns into C equals 14 over sine 54. Now, if you didn't know you could do that, I do know that you could multiply by C on both sides, right? And then you can divide both sides by sine 54, and it ends up looking like that. But if you haven't processed this, it's a pretty slick way to do it. Just those two get reversed. Okay, cool. Either way, it's 14 divided by sine 54. Dice of destiny. Row 6. Person 2, that's you. What'd you get? A little out of 17 point. Raise your hand if you had approximately 17.3. Okay, good. Now, what gets more complicated from here? Well, basically, we give you triangles where you don't have one side and one angle. And the simplest way we can do that is if we just give you two sides. We give you two sides, you can figure out an angle, and then you have a side and an angle, and you can go from there. So let's say this is 8, and let's say this is 9. Would you please figure out what theta is? I'll pause for a second, see if you know how to do that. So if you have any trouble with these, I recommend you just write out the equation with theta in it that you can use. I can use sine of theta is 8 over 9, and then what do I do both sides? What do you do to both sides? Inverse sine. Okay, that cancels that. Theta equals inverse sine of 8 9, so you got a calculator, you got some time, and you type it in, and what did you get? Raise your hand if you had about 62.7-ish. Okay, good. I'm not so worried about the rounding. We'll tell you where to round on the test. If you got it that close, you're going to be good enough. Okay, so how about the classic questions now? Name one of the kind of questions that we have done a few times that we should probably practice. What? Scrappy the dog. Okay, that's the one where you start off and you got a compass rose, and then you go like this, and then you stop, and then you go somewhere else, that kind of thing. All right, I'm going to just give you an overview quick before we do a real one. Okay, here's an overview. You'd know these two sides, wouldn't you? Let's say this is 8, and let's say this is 10. They almost always give you the two sides. Just ponder for a moment. If we can use like alternate interiors, and figure out things like that and that would have to be the same, and maybe based on the bearing they gave us for this, we can figure out what this green angle is. Do you get me? Might be in a scenario where we know that this is 105 degrees or something, and we have a side angle sandwich. What is the new formula that I just taught you? It can be used for that kind of thing where you got two sides and an angle in between them. Yes? A squared plus, hold on, I want everybody to see if you can recall it. Forcing you to recall it improves your memory. Try it. If you know that a squared plus b squared, blah, blah, blah. It's not a squared plus b squared equals c squared. More complicated than that, because it works for not right triangles. I'm not promising that they're always going to have this. But when they do have this scenario, holy cow, so much easier. How many of you remembered a squared plus b squared minus, what's the key part here? 2ab cosine of big C is equal to little c squared. They're different. Big C is the angle, and little c is the side across from that angle. Okay, so then if we're going to use that, one of these things has to be a certain letter, otherwise this formula won't work. Tell me what has to be what letter. Does 8 matter? No. 8 and 10 don't matter because they could be either what or what. This and this could be A or B, but this matters. That has to be the angle C. If you don't use that as angle C, this formula is irrelevant. It doesn't work. So if that has to be big C, then this side across from that is little c, and you can figure it out. All right, now some of you aren't going to process that because you're just not there yet. We will eventually have to know this formula to solve some problems. But you can do the Scrappy the Dog problem totally without that. And I'm totally okay with you doing it without that. All right, so let's talk about how you would do this problem if you weren't going to use law of, which one was that, by the way? Law of what? Cosines. All right. If you wanted to do it without that, then what you got to be able to do is be very careful with your angles. And let's say that my final answer is going to be this blue line. Okay. The key is that this triangle I just gave you is not a right triangle. Therefore, you can't use it to do a trig until you either make it into a right triangle by dropping a hypotenuse. That can work, but it doesn't always work. The way that it'll always work for this, if you're not going to use one of those laws of sines, the laws of cosines, is to go around the outside of it. You go like this. You know why? Because that's a triangle where I have a side of it. And I probably have been given an angle of it. And that means I can know all of its sides. And then there's this one, which is definitely shorter on the side here. This side right here, definitely a little shorter. But again, I have a side of it. And I probably was given this angle at the beginning. And so therefore, I know all these sides. And then last but not least, there's another triangle around the outside. I'll make it in red. And that's this guy. That's also a right triangle. And I would call this L1, L2, and L3 for the lengths, you know, length 1, length 2, and length 3. And length 1 and length 2 will add up to length 3. Do you get, we don't know length 3, but we can find it because it's in a triangle where we have a side and an angle. And we can also find this one because it's in a triangle where we have a side and an angle. All right. And then do you see, I've already drawn them, do you see H1, H2, and H3? This is like H1, this is like H2, and this is like H3. And H1 plus H2 is equal to H3. Which is the one that we would not know? H1, H2, or H3? H1. There's no way to know H1 because we don't have any sides of its triangle yet. You know what I'm saying? Okay, so then we must know this one because we have, it's part of this triangle here. And we'd know this one because it's part of this triangle here. All right, that's the big overview of the scrappy dog, the dog kind of question. All right, now I want to give you one. And there's a good one in here that's already pre-written, so I can find that. I'll pause for a second. Okay. It's on this page. Can anybody tell me in your document what page that's on? 7. Thank you for checking. Double check, is that 7 on other people's document too? Maybe it's because you added a page. 6? Okay, so page 6 or 7, depending on whether you added a page or not. Find this document. Do you get that this is the Scrappy the Dog kind of question? All right. Now, there's another kind here that's also a really good review question, okay? And that is the lamp pole is leaning question. Let's talk this one through just for a minute. Don't start the Scrappy the Dog question. I think you already get how to do that. I know you're tempted to want to do that, but learn how to do this one first. Do you get that the key to this is find the lamp pole, and therefore I wish that was just a right triangle, but it's not. If it was a right triangle, I'd already have an angle and a side, and I'd be done. It wouldn't be an R3 if that was the case. So we better not just use that triangle. We better either, remember how to make triangles? You either take one that's not a right triangle and split it into 2 triangles that are. See what I mean? That would be a right triangle, and that would be a right triangle. Or, and sometimes and, you can make triangles around the outside of them that are. But that green triangle I just drew, that would not be a right triangle, so that doesn't help very much. Could I draw a right triangle over here, maybe? You could. I don't think that would help very much. On this kind of a question, maybe this is the time it's best to split this puppy down the middle. And now, when I say it's 8 degrees from vertical, you get that means that if I pushed on my pole like this way, the pole would get back to vertical. And that dotted line right there, that was vertical. So that 8 degrees is how far off of vertical it is. All right, I believe you now have enough information to build both of these. I'd like you to try to answer both 1 and 2. Those are 2 of the classic trig questions that we've worked on already. And this is really important and powerful review for Friday's test. All right, I'm going to pause for a minute while we try these 2 quick review questions. So some help on number 1. First of all, let's just see if everybody's got it right, which I'm doubting, but then I probably don't need to spend much time on it. But 20.6, raise your hand if your group got 20.6. Holy cow, almost everybody has it right. All right, then just some quick advice about it. If you didn't get it right, here is the key. This triangle right here, I think, is critical, because why? Because I know all three angles of any right triangle if you just give me one of the other angles, like this, and this is right, obviously, and therefore that angle was known. And as soon as we knew that angle, then this right triangle becomes important. Right here, that triangle also is a right, and if I know this one, now I have one side and one angle and a right triangle. But wait a minute, you're saying, I don't have this angle, Mr. Server. You do. You have this angle's a 90, and this side you know because it's in a right triangle. This right triangle, you know one side and one angle. Okay, enough advice on that one. Now, how about the Scrappy the Dog question? How many of you guys are done with that one? Only a few. All right. You want a hint that would save you a gajillion hours? A squared plus b squared minus 2ab cosine c. Why? Because I have a side angle sandwich. Where are my two sides that obviously only intersect in one spot? They're at the bottom there, the 12 and the 18. Then, Mr. Server, we don't know this angle. Oh, yes, you do.
25.
Why is it 25? Because it's a what? Do you remember the name? Alternate interior. Yes. I'm going to show you why it's an alternate interior. Watch. Extend out your north-south line, extend out your north-south line, and you got two parallel lines. Just a second. Then, this, hold on, issues. Then this angle has to be the same as this angle. Therefore, that's 25. Therefore, there's a total of 100 down there. 100-degree angle in there, side angle sandwich, and that's the easy way to do it. Now, I know a lot of you didn't do it that way, which is fine, so let me show you the other way. If you're not going to do that, you still should use that technique to figure out that this is 25. That helps a lot. Okay, and if that's 75, then I can start designing my triangles that are outside the box, so to speak. They're outside the other triangle. There's one of them. I know a side and an angle of that one, because this must be 15, because it has to add with the other one to make 90. So I've got a side, I've got an angle, I know all the other sides. Next, another triangle, this green one. That's a right triangle where I know a side and I know an angle. Pretty easy and quick. And last but not least, I'll do it in bright pink. This triangle, it would run across the top here. There, there. That triangle. That's the one where I don't know any of the sides, but I can find them by using the others. This one, I'm going to call H1, H2, nope, I'm wrong. H1, H2, and this will be H3. They add up. H1 plus H2 equals H3. I totally understand that you guys have to leave, but I am going to continue the recording for other kids who aren't here today to explain the rest of how you do this one. And if you want to see it, go ahead and watch it. Have a good day. Your homework for tonight. Just wait. Pause. All right, so I told them to do the last 3 questions in the file here, or first 3 of these, under Chapter 10 Mega Review page. I said to do problem 1 and 2 right there, and then this one, the bat signal one, number 3. That's their homework for tonight. Okay, now I'm going to go back for those that want an explanation of how to do one last one of these review problems. Okay, so just doing a last wrap up here to help you see how you could have done this without the law of law of cosines. We have H1 and H2 would add up to H3. H2 we would know because it's part of this triangle here, and in this triangle we have a side and an angle, so we can know that one. This one we would also be able to know because it's part of this green triangle here where we have one side and one angle. And so then you would just take the H3 and subtract the H2, and that's how you could get the H1. Now I've got this little side of my pink triangle. Now how about the big pink side. I'm going to call that L3. I hope you can see that L1 plus L2 adds up to L3. So if I knew this one, which I do because I have a side and an angle, and if I was in this triangle, I also could know L2 because I have a side and an angle. Added together, they equal L3. Now, why is it so neat that I know two sides of this pink triangle? Because then I can figure out this angle right here, this little angle of the right triangle, by using, let's see, it would be tangent, yep, opposite over adjacent, yep. So it would be inverse tan of the H1 over the H3. And that would tell you this little angle. Now I got a side and an angle, and I can figure out anything in the pink triangle, which of course means I can find the distance and the bearing at C. All right, so I could figure out in here, my final answer here comes out to 23.3 degrees east, 15.5 degrees south. Now, isn't that wonderful? They didn't give us true bearings, but if, oh, sorry, I'm just reading this wrong. The distance and bearing, sorry, its distance is 23.3, and the bearing is east, 15.5 degrees south. Basically, if I were to blow that up, east 15.5 degrees south is like this. That'll also be known as 90 plus the 15.5, which would be 105.5 degrees for the bearing. All right. So, all right. Oh, wait a minute. I just making sure I did this right. Yep, actually I did it right. Okay. All right. The distance and bearing at C was what we were trying to find there. All right, and that's all I have for you for today's video.